Hi there. As I alluded to in the first video, it's not a problem to simulate one classroom of 23 individuals and check to see if there's at least one pair of individuals with the same birth date. So the problem is if you want to keep doing this simulation over and over again, it's going to become time consuming. So the command from the front side of the handout, very similar to commands we've done in class, press the math button, select probability, and go down and select option 5. That's the random integer option. So I want 1 and 365 to be my lower and upper boundaries for generating my random numbers. I want to generate 23 of them. I'll close my parentheses. So I'm going to press the store button. That's over here to the left of the number 1. I'm going to store this into list 1, second 1. So now I want to glue another command to this command. So I need to press the alpha key and then come down here and press the decimal point button. That will give me a colon. The colon literally says take one command, execute it first, and then glue this next command to it and do it second. So to get that second command, I will press second stat button. I want to sort my list ascending. So I'll press the right arrow to go to ops. We used sort descending and sort ascending. We used one or the other of those in class, depending on the way we did your simulation that we practiced in class. So I'm going to choose sort ascending this time. So the numbers will go smallest to largest. And I need to put in list 1, second 1, and close my parentheses. There's the command. So if I press enter, it'll execute the command, but to understand whether or not I do or don't have at least one pair of individuals with the same birth date, I have to hit the stat button and press enter. I have to go into the list and take a look. So let's scroll down. I'm looking for a pair of numbers that match. I still don't see any. I don't see any. I'm still looking. Oh, there's one. Right there, notice there's a 280 and a 280. So right there, this represents a classroom of 23 individuals where 2 of them were born on date number 280 out of 365. Now you can keep looking for pairs if you want to, but I don't have to because I already know that this represents a sample where at least one of the pairs of individuals indeed shared a birth date. Just for kicks, oh, there's another pair. So we don't count this twice. This is still just one sample where at least one group, one pair of individuals shared the same birth date. There we go. So the idea, though, is to do this simulation again, I would have to go back to the home screen, execute the command, come back here to the list and inspect the list again. And it's going to take time to do this simulation over and over again many times. That's why I'm going to have you write a simple computer program that's going to automate this process of actually going through the list and inspecting to see if you have any pairs of individuals that share the same birth date. So this is actually what the computer program will look like. It only has 6 lines. So in the next video, I'm actually going to take you through step by step how to write the program. So don't worry about that. On this video, I want to take you through the logic and make sure you understand what the program is about to automate for you. So line A of the program takes the number 1 and stores it into the variable n. So we're going to use n to represent the line number in our list that we happen to be working with, or the entry in the list that we happen to be working with. So for instance, this is list entry number 1, this is list entry number 2, and so forth. Line B of the program establishes a condition. A condition that we're going to check. Now notice n is 1, while the value of n is less than or equal to 22. So right now n is 1. 1 is certainly less than or equal to 22. So as long as that condition is true, all of the lines up to end in line E will be repeated. So as long as this condition is true, these 3 lines of the program are going to be repeated over and over and over and over again as long as this condition is true. So here we go. since 1 is less than 22, line C of the program will check to see if, now look what it does, it takes the value of n, which is 1, so 1 plus 1 is 2, to see if list 1 entry number 1 plus 1, or list 1 entry 2, to see if it is equal to list 1 entry number 1. So notice that value of n, which is 1, goes here and here. So we're really saying list 1 entry number 2, is it equal to list 1 entry number 1? Is list 2 equal to, rather, is list 1 entry 2 equal to list 1 entry 1? So literally, here's entry number 1, here's entry number 2. I'll actually label it here. Here's list 1 entry number 1, and here's list 1 entry number 2. Those are not equal to one another. Those are not equal to one another. So notice, if this is a true equation, so if this statement in line C, if that is a true equation, the number 1 will be stored into list 2. So the number 1 is going to get stored into list true entry number 1, n is 1. Since in the screenshot above, though, this is a false statement, the number of 0 is stored instead. So if this condition is not true, this condition generates a 0, and a 0 is stored into list true entry number 1. So that's what we're going to get right here. These two are not equal. So that means into this entry in list 2, we get a 0. Now, look at what D does. Line D says it assigns 1 plus 1 or 2 to be the new value of n. So notice what's happened here. N is 1 right now, but 1 plus 1 makes 2. So now n has been increased to 2. We reached the end statement, so we're going to go back up here and check the condition. 2 is still less than or equal to 22, so we are going to repeat lines C and D, and that's what I've written for you down here. Since 2 is less than or equal to 22, line C will check to see if, now, remember, n is 2. So now up here, 2 plus 1 makes 3. N is 2, here and here. So we're going to check to see if list 1 entry 3 is equal to list 1 entry 2. That's what we're doing here. N has now been increased to 2. 2 plus 1 makes 3. So is list 1 entry 3 equal to list 1 entry 2? Well, take a look. Here's list 1, here's entry 3. So we already checked these two. So now we're checking these two. Those two are not equal to one another. If they are not equal to one another, then the value that's stored into list 2, now remember, right now n is 2. So we're going to store a 0 into list 2, entry number 2. Here's where entry 2 would be in list 2. It is also a 0, and it's a 0 because these two birth dates were not the same. So we just wrote the value to be stored into list 2 above. Okay, well, now we're going to repeat. Line D assigns 3 to the variable. So notice what's happened here. In line D, right now, n is 2, but now we're going to take the 2, add 1 to it, and make n 3. And we're going to cycle back up to this condition. When the end is reached, we go back and check this condition here, and 3 is less than or equal to 22, and so this logic continues once again. So now, again, we're going to check to see if, now remember, n is 3, so now 3 plus 1 makes 4. Here's 3, and here's 3. So literally, I'll write it in this time. So literally, when n is 3, this says take list 1 entry number 4. Here's where it would be, list 1 entry number 4. There it is. And we're going to check to see if it's equal to list 1 entry number 3. So we're checking these two now. Are those two the same? And in fact, those two are the same. So this is what we're doing. In line C, we're going to see if list 1 entry 4 is equal to list 1 entry 3. So now notice those are the same. So this right here really does equal this right here. This is a true statement. So we're not going to store a 0 into list 2 entry number 3. This is a true statement, so a 1 is going to go in here. So here's the third entry, we get a 1. And that's really special right there. So this is going to continue cycling through. This is going to continue cycling through until n turns out to be, this will check up until n equals 22. So understand, when n is 22, 22 will be less than or equal to 22. So, but then notice 22 plus 1 makes 23. So we'll be checking to see if the 23rd entry is equal to the 22nd entry. But notice what's going to happen after that check occurs. 22 plus 1 will make 23. 23 is not less than or equal to 22. So all of this logic will stop. And we'll skip to the next line after the end. And this is what will happen. This is all that essentially you're going to see on the home screen. So what's going to happen is you're going to get the sum of list number 2. As we check these conditions over and over again, we're going to get a sequence of zeros and ones. So if we get, understand, if we get at least one shared birth date, then we're going to get at least one 1 in list 2. So all I care about is the sum of list 2. If it is at least a 1, then I know I have a sample of size 23 in list 1 where at least one of the pairs of individuals shares the same birth date. Now, I could get a sum of 2. That would mean 2 pairs of individuals essentially share the same birth date. So I don't really care about what the value of that sum is. I just care to see if it is at least 1. If it's at least 1, then I'm good to go. So here's the idea. The bottom line, if the sum from F is 0, you know the sample had no shared birth dates. If it's at least 1, then you know that there are shared birth dates. So what we're going to do here in the next video, we're going to build the program. So ultimately what we're going to be able to do after we've built this program, we'll have the random integer command that will execute just like on the front. So we'll still sort our list ascending, but then we're going to glue a new command to the end of this command. We're going to run the program bday. We're going to write this program in your calculator, and we're going to tell the calculator to automatically run that program, so it will immediately be able to check the sum of list 2, and we'll be able to tally up very quickly. When are there shared birth dates in our sample of 23, and when are there not shared birth dates in our sample of 23? And we can use that comparison in order to estimate the probability from the beginning of the handout, probability number 1. And I'll want you to write it as both a fraction and a decimal. So this was ultimately what we were trying to estimate, and this is what the program will let us do. Here's probability number 1. At least one pair of individuals shares the same birth date. All of this work to go back and estimate this by simulation. Click on the next video, we'll write the program together, and then I'll show you how to use it. You'll be good to go.